Thank you. So I actually slightly changed the title of my talk. I'd like to talk about something that I'm really excited about, things that we've been starting to look at in the past 2 years, what we call deep internal learning. What do I mean by that? Well, we're all used to external learning. That is to say, we train a network on externally labeled data, lots of training data, and we train it for days or weeks or whatever, and then when a new test image comes in, we apply our deep network on this, our trained deep network on this new test data, and out comes the result. And there has been tremendous progress. I don't have to tell this community how much progress there has been done using these kind of techniques. However, what happens if we don't have enough external training data? Or worse, what happens if our external training data is irrelevant to our new test data? And what I'd like to show you is how we can overcome these situations by replacing external training with, it doesn't work. Okay, I guess I need a new, wait. Okay. 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 So what I'd like to show is how we can overcome some of these problems by replacing external training with internal training. Training directly on information extracted, on examples extracted from the test datum itself. And as I'll show, this can be done by exploiting the internal redundancy within visual data. So what do I mean by internal redundancy? Well, there's lots of repetition inside a single natural image, both within the same scale as well as across different scales. When I say that there is a repetition within the same scale, I mean that if you see a small patch once inside the image, you'll almost surely see it many more times inside the same image. Now here I'm showing you relatively large patches, but in practice I'm talking about much smaller patches, 5 by 5 or 7 by 7. And this kind of repetition has been exploited by us and by others for a large variety of applications, including image completion, denoising, like non-local means, BM3D, and so on, visual summarization, and much more. Less known, but also very strong, is the recurrence of information across scales within a single image. And what I mean by that is if you take the image and scale it down, then almost any patch in the original image will almost surely find an almost identical patch to it in the scaled-down version of the image without scaling down the patch, which means that the original small patterns are found in multiple sizes in the original image. And this property has also been used by us and by others